Hey guys, hi, welcome back. So in the last video, we have seen the electric field intensity due to dipole on the center. Now we will see the electric field intensity due to dipole on the axial line, or we can also say it to be the end-on position. Clear? So we know the axial line is the line which is passing along the axis of the dipole. So we will see here, first of all, let us make a dipole. So to make a dipole, we need the negative charge, right? This is minus q charge, and we need another charge, positive charge, equal in magnitude but opposite in nature. So this is the center of the dipole O. So I'm writing this to be A and this to be B. So we are having a dipole AB now. We know the separation of the dipole or the length of the dipole is what? It's twice L. Clear? So if this is twice L, this distance will be L and this distance will be L. Next, what we need to see is the direction of the dipole. We know the direction of the dipole is always from negative charge to positive charge. Clear? Now, since we are asked to calculate the electric field intensity on dipole on the axial line. So, axial line is the line which is passing along the axis of the dipole. So, this is the axis of the dipole. So, this line is said to be as the axial line. Now, we will consider a point P. Okay, I'm considering a point P on the axial line, and at that point P, I'm placing a test charge Q naught. Because we know when we are asked to calculate the electric field intensity, we will have to place a test charge at that particular point, because electric field intensity is the force per unit test charge, and we know the formula to be equals to E is equals to 1 by 4 pi epsilon naught Q by R square, or you can write KQ upon R square. Clear? Now, one more distance we will see, that is the distance from the center of the dipole to this point P. I'm taking this to be R. Clear? So, I have written here AB is a dipole of length 2L centered at O. P is any point on the axial line where the electric field intensity is to be calculated. So, we will do in the similar way. We will find the electric field intensity on the axial line. The steps are almost similar. First, we will write the electric field intensity due to the charge minus Q, then due to the charge plus Q. What we need to remember is that the magnitude of the charge in this formula will be same. K is also constant. We will have to just see the value of what? R. That is the distance between the charge due to which we are calculating the electric field intensity and the test charge. So first we will write electric field intensity due to charge minus Q. Okay. So E1 is equals to KQ by R square. So if you see minus Q charge, this minus Q charge is at a distance of how much? This R plus L, you can just see this is the entire distance of the minus Q charge, right? So this, if you see from the center, if you see, this is your R, right? And this is your L. So it will be what? R plus L whole square. Now, what is the direction of this electric field intensity? If you see in this particular case, this is a positive charge and this is a negative charge. Obviously, the negative charge will attract the positive charge and the direction will be minus I cap, right? So we will write here the direction to be minus I cap. Similarly, we will write for the charge plus Q. So similarly, electric field intensity due to charge plus Q. So we will write this to be E2 is equals to KQ by the distance, right? So what is the distance this time? This is the plus Q charge and this is the point. So if you see in this case, the distance between this plus Q charge and the test charge is only this much, right? So you can just do what? You can subtract from this R, this length you can subtract. That means this is only the distance, right? So from the entire R, if you subtract this L length, because this length was what? L. You can just see this length is your L. And from this point O to this point P, it's what? R. So you will write it to be R minus L whole square. Now, what is the direction? If you see here, this is a positive charge. This is also a positive charge. So positive and positive charge will repel each other, right? So the direction of E2 will be in this particular direction. Clear? So it is plus I cap. All right. I think this is clear. So if it's not clear, I'm just using some other color highlighter so that you will understand it more well. Okay, just to see the distance. If you see for this plus Q charge, we took the distance to be what? This is the entire distance, right? This is the entire distance. Clear? So if you see here, this distance is, this much distance is L, and this center to this point P, the distance is how much? R. So I have taken it to be R plus L. But for the point B, that is the plus Q charge, the distance is only this much. Okay, this distance will be how much? From this entire length, we will subtract this length. So this entire length from the center is R. We need to subtract L. So it's R minus L. Clear? I hope this is clear. So now let's come to the calculation part where we will calculate the electric field intensity. Okay, the net electric field intensity. So the net electric field intensity at the point P is, we will just add it. So E is equals to E1 plus E2. Now we will put the values that we have written. This is only E, okay? It is KQ by R plus L whole square, okay, with a minus I cap. Clear? Again, plus KQ by R minus L whole square with a plus I cap. Done. So now what we will do is we will take common KQ. Within the bracket, what we will have? Minus 1 by R plus L whole square plus 1 by R minus L whole square, and outside of the bracket you will have the I cap. Okay, now let's do the calculation part. So here if you see, E is equals to KQ, means K is your 1 by 4 pi epsilon naught. Okay, the charge Q is here. Now we will do the basic derivation. Okay, simplification. So if you see here, we will take the LCM. So it is R plus L whole square, and this is R minus L whole square. So if you will take, this will be a negative sign. This is R minus L whole square, right? Because you are having here R plus L whole square plus R plus L whole square. So this is what you are getting. Then in the next step, we will write Q by 4 pi epsilon naught. Now, if you see the denominator, this is A plus B into A minus B. That means you can write it as R plus L into R minus L whole square. Clear? This is your I cap. So if you see here, minus, this is A minus B whole square. So directly you can write A square plus B square minus 2AB. Same, it's A plus B whole square, that is A square plus B square plus 2AB. Remember, this is for the plus A plus B, this is for A minus B. So now what we will do? E is equals to Q by 4 pi epsilon naught. Okay. Now we will take the negative sign inside, and we will have minus R square minus L square plus 2RL. Again, plus R square plus L square plus 2RL. In the denominator, we can write A plus B into with A minus B. And the formula is what? A square minus B square. So the A is R. So R square minus B square, that is L square. Clear? And this square will be outside. And this I cap will be here. Now, if you see here, this minus I square plus I square gets cancelled. This minus L square, this minus plus L square gets cancelled. Clear? So this is what we got. E net is equals to Q by 4 pi epsilon naught, cancelling the minus R square and minus. So what we will write, E net is equals to Q by 4 pi epsilon naught. So 2RL and 2RL we will add. So we will get 4RL, and this is R square minus L square whole square with I cap outside. So now what we will write is E net is equals to Q by 4 pi epsilon naught. Keeping it same, the denominator will be also same, R square minus L square whole square. But this 4 I can write is as 2 into with 2RL. Okay, and the I cap here. So rearranging it again. So why I have written it so? Because we know the dipole P. Okay, dipole strength P is equals to magnitude of either charge into with the distance between them, Q into with 2L. So this is what I'm going to do. I'll just take Q and 2L on one side. So I'm rearranging it as Q 2L, and this side I am writing it to be 2R divided by 4 pi epsilon naught. Within the bracket, you're having R square minus L square whole square I cap. So we will just substitute the value of P here for this Q into 2L. So you will have what? P, and this is 2R, okay, by 4 pi epsilon naught R square minus L square whole square with the I cap here. Done. Next, what we will do, we will just write 1 by epsilon naught to be 2kp. Okay, I'm writing it to be k, and this is R, and you're having R square minus L square whole square I cap. Done. That means this I cap shows you the direction. So this is the electric field intensity for the axial line. Okay. Now, if you are having a very short dipole, this is a special case. So this is for special case, that is for short dipole. Okay. For short dipole, if the length of the dipole is very short, that means when L is very, very less than R, in that case, L is equals to 0. Okay, we will ignore the value of L, and we will get the electric field E to be equals to 2 kpr. Okay, divided by, if you ignore, you make L to be 0, you will have what? It is R square into with 2, so it is R to the power 4 with I cap. So you can write it E is equals to, this R will cancel 1 R from here, so you will have 2 kp by R cube. Okay, I cap. So this is the electric field intensity for short dipole on the axial line. Done. So this is how you can calculate. The only thing you will have to remember is that you need to write the electric field intensity due to both the charges, then add it up. You need to see the direction of the electric field intensity, and you need to take care of the distance R. Okay, so that's all in this video. Thank you so much. Have a good day.